Hello everyone. In this interaction, we will take up class 10th fourth chapter, that is quadratic equations. And in this particular video, we'll discuss the overview of the chapter and take up the first exercise 4.1 of this quadratic equations. So let's begin. First of all, quadratic equations, let's decode it literally. What is quadratic? Quadratic is something associated with the degree. Means quad Quadratic stands for degree 2, and equation is the statement of equality. Any expression having the sign of equals to is an equation, right? So in this particular chapter of class 10th, any equation which can, or any expression which can be rearranged in this form, ax square plus bx plus c equals to 0, is quadratic equation, where with the condition that a, b and c are real numbers and a is not equal to 0. Okay, why? Because if a is 0 in this expression, this equation, then this becomes 0, right? And our equation will no more be quadratic, it will be linear, right? That's why a is not equal to 0 and a, b, c are the real numbers, and this form is the standard form of quadratic equation, right? So any equation which can be rearranged in this form, where a, b, c are real numbers and a is not equal to 0, is the quadratic equation, and this form is the standard form of the quadratic equations. Now, solution of the quadratic equation. By solution, we mean the value of the variable which satisfies the equation. That is the solution of the quadratic equation. Means we replace the variable with certain value and it satisfies the equation. A satisfying equation means left hand side and right hand side both are equal. In this case, left hand side is equal to 0. By replacing the variable with particular value, then that value is the solution of the quadratic equation, right? And we name it roots of the equation in case of quadratic equation, and it is same as the zeros of the quadratic polynomial we discussed in chapter 2nd of this class 10th. Okay, now let's discuss about the nature of the roots of a quadratic equations. Means what kind of roots are possible and how the nature of the roots can be defined prior to solving the equation. The first thing, that standard form we must keep in mind ax squared plus bx plus c is equal to 0. Then as nature of roots is concerned, maximum two values are possible. Means two roots, maximum at max two values are possible for the equation, right? Two roots, maximum two roots are possible. And what kind of roots are they can be defined by this expression b square minus 4ac. Now see, as a, b, c are real numbers, we are here with an expression involving numbers with operate with certain operations plus minus and multiplication squaring. So whenever numbers we perform, means some calculations on the numbers, we are left with three possibilities. First one is that is greater than 0, equals to 0, or less than 0, right? Accordingly, the nature of roots the of quadratic equations is defined. If the value is greater than 0, we'll have two distinct real roots. If it is equal to 0, then two equal real roots are possible, and if it is less than 0, then a real root does not exist for that particular equation. Okay, and this expression b square minus 4ac is the discriminant of the equation. So nature of the roots is defined by the discriminant b square minus 4ac of the equation. If it is greater than 0, two real roots are possible. If it is equal to 0, two equal real roots, means coincident roots, are possible. And if it is less than 0, real root for that equation does not exist, right? So now let's take up or let's discuss the methods of solving a quadratic equation. Finding the roots of a quadratic equation. In this chapter, we'll discuss three methods: factorization method, completing the square method, and quadratic formula for solving the quadratic equation or finding the roots of an equation. First one, factorization method. We'll express the equation as a product of two linear polynomials, px plus q plus rx plus s is equal to 0, and then comparing each equal with 0 we'll find the value of x, or we find the root of the equation. Second one is completing the square method. In this we'll complete the square with first two terms of the equation to get it in the form of either a plus b whole square or a minus b whole square by adding and subtracting b square of the identity, right? Adding and subtracting simultaneously means we are doing nothing with the equation. Okay. Then by equating the square with other part of the equation, roots are found. Now to add and subtract b square, we first find b, right? What is b of this identity in that particular equation? Okay. Exactly. It looks a bit complicated, but believe me, it is as easy as the table of two. When you do this, you'll come to know it. Okay. Third method is quadratic formula. The value of x or the variable can be found by this formula, that is minus b plus minus under root b square minus 4ac whole upon 2a. Okay. Plus minus one time plus one time minus two values of x, as we discussed that there max two roots are possible, right? Now let's take up first exercise and first question that check whether the following are quadratic equations or not. Now before going into the exercise or questions, the first thing I want to convey to all the students out there that the best method of learning mathematics is drilling by ourselves. Means once the method is clear to us, right? Once the formula is clear to us, once the procedure is clear to us, if we can take up maximum questions by ourselves or can solve maximum questions by ourselves, then and only then we can learn mathematics in a better way. Means doing questions or sums by ourselves, not only we are learning that particular exercise or particular chapter, but by doing so we also brushing our skills, general skills, calculation skills and all that, right? So it is a request also, rather than to practicize or to drill by ourselves to maximum we can afford, right? Let's take a first question. Now see, any expression which can be rearranged in this form is quadratic equation, right? So here is our sum: x minus 2 into x plus 1 equals to x minus 1, x plus 3. There is no square, there is no cube, right? That's why I said any expression, any equation that can be rearranged. So we'll rearrange it, we will simplify it, and let's see what we get. Let's move to our blackboard. So multiplying algebraic expressions, right? We multiply both sides, multiply x with this by minus 2, same here by x and minus 1. Then we open the brackets, we get this, right? X square plus x minus 2x minus 2, x square plus 3x minus x minus 3. And after all, we have to rearrange this, right? Like terms, x minus 2x is minus x. Similarly here, 3x minus x is 2x. Then we'll shift to the one side, x square minus x. This by transposing here, we'll get minus x square. Minus x minus 2x minus 2, and this is minus here plus 3. Simple, by transposing method we take all the terms to one side, and after simplifying we get this minus 3x plus 1 is equal to 0. So clearly this is not in this form, right? And this is not a quadratic equation. Okay, let's take up the second. X square plus 3x plus 1 is equal to x minus 2 whole square. Let's rearrange it also. Left hand side is already bracket free. X minus 2 whole square, a minus b whole square identity. We open it, right? And then we shift all the terms to one side and simplify further the like terms, adding and subtracting. We are left with 7x minus 3 is equal to 0. See, x square minus x square cancels out. So we are left with this expression 7x minus 3 is equal to 0. Clearly again is not in the form of ax square plus bx plus c is equal to 0. So this is not also a quadratic equation, right? Let's take one more example, that is x plus 2 cube plus is equals to 2x into x square minus 1. So let's now see, here we will apply a plus b whole cube, a cube plus b cube plus 3ab into a plus b, right? We'll apply this to this left hand side and we'll open the bracket here, 2x into x into it is 2x cube minus 2x into 1, that is 2x. Again we'll open this bracket, 6x squared plus 6 to the 12x, right? And simultaneously we are shifting these two to the left hand side, so we are left with this one, x cube minus 2x cube is equal to minus x cube plus 6x squared plus 14x. This is simplified, so this is again not in the form of ax squared plus bx plus c is equal to 0, so this is not a quadratic equation, right? Let's take one more. X squared minus 2x is equal to minus 2 into 3 minus x. So by rearranging it, and we get this x squared minus 4x plus 6 is equal to 0. This is a quadratic equation as it is in the form of ax squared plus bx plus c is equal to 0, right? So we saw that the expressions, we first arranged them, rearranged them, simplified them, and check whether the simplified expression or equation is in this form or not. Okay. Okay, let's move to second question. We are given certain situations and we have to form the quadratic equation out of them. This one is my favorite one, and word problems. The question is simply, in a situation, first we have to extract the question, then we have to solve it. Just a fun, just so much fun, right? Interesting part, and we get word problems throughout. So let's see what kind of word problem is here. First one. Yeah, the area of a rectangular plot is 528 square meters. The length of the plot in meters is one more than the twice of its breadth. We need to find the length and the breadth of the plot. So let's move to blackboard and try to put the word in numbers and equations. Now we are given the area of the rectangular plot. Area is length into rectangular length into breadth. Length and breadth are given in a relation to us. And what kind of relation is given to us? That the length is one more than twice of its breadth. So we'll suppose, or will the length, the breadth is x meter. Let breadth of the plot is x meter. If the breadth is x meter, then length is one more, then twice of the x is 2x, right? Twice of the breadth, x is 2x, and one more is 2x plus 1. So then length will be 2x plus 1 meter, right? And Now area, length into breadth is equal to area. Length is 2x plus 1 and breadth is x. So 2x plus 1 into x is equal to 528. By solving it, rearranging it, simplifying it, we get 2x square plus x, right? X multiplied to this. 2x into x, 2x square, 2x into, x into 1 is x, and 528 transpose to left hand side, it is minus 528 is equal to 0. So we get 2x square plus x minus 528. We get the form ax square plus bx plus c. Let's see the second one. The product of two consecutive positive integers is 306. We need to find the integers, positive integers, and they are consecutive. So if we take first integer x, second one will be x plus 1. Simple, right? And according to question ATQ, that the product is 306. So x into x plus 1 is good. This is so simple. So we'll simplify left hand side by opening bracket, multiplying with the x, we get x square plus 1, and shifting 306 to the left hand side, we'll get this simplified equation x square plus x minus 306 is equal to 0, and it is in the form of ax square plus bx plus c is equal to 0. So this is the quadratic equation from this situation. Let's see, we have some more. Yes. Here, Rohan's mother is 26 years older than him. The product of their ages in years 3 years from now, not now, 3 years from now will be 360. We would like to find Rohan's present days. Rohan's present days. So we will suppose that Rohan's present age is X years or Y years, whatever you want to take. Means we suppose that Rohan's present age is X years. So 3 years from now, before that, according to question, in a situation given the question, that his mother is 26 years older than him. So his mother's age will be X plus 26. Now from 3 years from now, Rohan will become X plus 3 years old, and his mother will be X plus 26 plus 3 years. That is X plus 29 years old, right? Now, according to question, the product of their ages after 3 years, that is X plus 3 into X plus 29 is equal to 360. We'll simplify it, rearrange it, and see what we get. So X square, now see, we'll x plus a into x plus b to left hand side. If we can recall that identity, that is x square plus a plus bx plus a into b. So we get x square 32x plus 87, and shifting or transposing this 360 to left hand side, taking this to left hand side, this is 87 minus 360. So after simplifying it, we'll get x squared plus 32x minus 273. 273 is equal to 0, which is our required quadratic equation for the situation. See, so what we actually are doing in these questions, these situations, we are putting the words in numbers and mathematical operations, right? So as I said earlier, that by drilling or by doing ourselves, we will be able to means extract these equations from the words more easily, right? And we can solve it only after we can extract the equation, we can form the equation accurately. So keep drilling, keep doing, keep practicing, right? Let's see this. A train travels a distance of 480 kilometers at a uniform speed. So here speed and distance is involved. So first click will be the formula for the speed, distance upon time, and then playing with that formula for distance and for speed, for time, sorry, right? So if the speed had been 8 kilometer per hour less, then it would have taken 3 hours more to cover the same distance. We need to find the speed of the train. Okay, so language understanding is plays a major role in mathematics also. If we understand the words, we understand the language. Okay, let's see. Now here, as I said, that speed and time, distance. So the formula for speed, that is distance upon time, comes into play. And from this particular equation, this is also an equation, we can derive formula for time, that is distance upon speed. We can derive formula for distance, that is time into speed. And let's see what out of these we can use in this particular situation. So let distance covered by the train is 400 kilometers. That is given to us. We'll suppose the speed of the train is x kilometer per hour. Okay, then time will be given. Time, distance upon speed, distance upon a speed, 480 upon x hours. Okay, then according to question, uh, just understand this very carefully. And according to question, if speed is lower, if speed had been 8 kilometers less, if speed is equal to x minus 8 kilometer per hour, then 3 hours more, means time would have been 480 upon x, that is the time, right? If speed is 8 kilometer less, then time will be 3 hours more to cover the same distance. Now see, time into speed is equal to distance. Time into speed is equal to distance. We'll apply this to get the equation. We fill the value, time, this 480 upon x plus 3, speed x minus 8 is equal to 480. After then we'll simplify it, remove the brackets and see what we get. Here first, x is LCM, so this 480 plus 3x upon x into x minus 8 is equal to 480, right? We'll shift x to this side, transpose x to this side, it will be multiplied into 480, we'll get 480x on the right hand side. After that we'll open these two brackets and we'll get this multiplied by x, 480x plus 3x square minus 8 multiplied into 480, we get 3840 minus 8 3 is a 24x, and we'll shift this 480x to left hand side, minus 480x is equal to 0. Again simplify it for a bit more, 3x square minus 24x, 480x minus 400, these cancel out, right? So 24x minus 3840 is equal to 0. And if we multiply it by 3 throughout, sorry, divide it by 3 throughout, we get x square minus 8x minus 1280 is equal to x, which is in the form of x square plus bx plus c is equal to 0, right? If we have to identify a, b and c here, a is 1, b is minus 8, c is minus 1280. Okay, don't confuse by these minus signs, right? So this is how situation is there and we extract the equation. We can solve, or we will solve it, we can find this speed of the train after solving this equation, right? But we are able to solve the equation, do the question only after we can put these words in the equation. Okay, so this is these two questions are there in exercise 1. One is identifying or identifying the equations as quadratic equations or not, and second one is extracting the equations from given situations. So let's quickly wrap up what we have discussed in this video. Quadratic equation means an equation which can be rearranged in ax squared plus bx plus c is equal to 0, where a, b, c are real numbers. A is not equal to 0, and this is the standard form of the equation, right? Then we discussed about the solution of the quadratic equation. This maximum two values are possible, maximum two roots are possible, and the nature is decoded by the discriminant, that is the expression b square minus 4ac, and the b square minus 4ac involves three real numbers bounded by certain mathematical operations. We are left with three possible results: greater than 0, less equal to 0, or less than 0. Accordingly, the nature of roots, right? Two real roots in case discriminant is greater than 0, coincident roots, two equal roots in case discriminant is equal to 0, or no real roots in case discriminant is less than 0, right? Then we discuss the methods of solving the equation. Three methods we are discussing. We'll discuss in this chapter, that is factorization, completing the square and quadratic equation, quadratic formula, that is x is equal to minus b plus minus under root b square minus 4ac upon a 2a. So this is the quick wrap of this video. We discussed, and we'll discuss in further videos when we'll do exercise 4.2, 3, and 4. We have 4 exercises in this chapter, right? So that's it in this video. I'm leaving you with this small extract from a song, that we should not give up, right? Okay.
Don't give up on us, baby. Lord knows we've come this far.
Keep supporting
We
us,
stay the
right?
way we are. The angel and the dreamer, who sometimes plays a fool. Don't give up on us, I know we can still come through.
Thank you for watching.